In this video we're going to try and sketch this graph here. So let's see what happens when we put 0 into here. So when you put 0 into there, it would be 0 over 0 squared plus 4, which will be 0. So when it's 0, we know it passes through the origin. Let's see what happens at 1 and at -1. So when you put 1 into there, it would be 4 over 5. Let's just imagine it's somewhere around here. And if you put -1 into there, it would be -4 over 1 plus 4. So that would be negative slightly less than 1. So it's going to be somewhere around here. So we know it passes through here, the origin, and here. Now let's see what happens when x tends to infinity. So let's look at this as x tends to infinity. When x gets very big, when x gets very big, the denominator will just act as x squared, because this 4 is going to be irrelevant. The numerator will stay the same. So let's simplify this. So that would be 4 over x. So as x gets very large, the graph is just going to act like this, meaning that when x gets very big, it's going to head towards 0 from above. So we know the graph will look something like this. Now let's investigate what happens when x gets very negative big. So what is the limit as x heads towards negative infinity? Well, when this gets well, you can imagine putting a very negative big number in there. So you can see that this thing here is going to head towards 0, and then you've got 1 minus in there. So it's going to be negative, very small. So it's going to look like this. It's going to approach 0 from below because there's a minus here. Imagine it as being, alright, put -1 million in there. You know that this is going to be very small, and there's a negative number in there. Well, there's a negative sign there, so it's going to be like this. So we know it's going to do this, and it's going to do this. So we can guess it's going to look something like this. Let's try and locate this point here, the local maximum. So if you want to find that point there, hang on. If you want to find that point there, then differentiate this, because at this point the gradient will be flat. It means the gradient would be 0. So find dy by dx, so differentiate this. So you've got to use the quotient rule now. V squared v u prime minus v prime u. So v squared would be this thing squared, x squared plus 4 squared. The v stays the same, so that would be, the v stays the same, so that would be x squared plus 4, it stays the same, and then you've got your u prime, which would be 4. I'm going to put it here, and then minus, and then v prime, so differentiate the v, so differentiate this would be 2x, and then leave the u alone, leave the u alone, leave the u alone for x. So if I were to tidy this up, it would be 4x squared plus 4 minus 8x squared over this thing here. So that would be our dy by dx. Well, if I want to find this point and this point here, where the gradient would be 0, I've got to put 0 into the gradient. I've got to put 0 into the dy by dx. So put 0 in there and try and figure out values of x where the gradient would be 0. Now times both sides by the denominator, so that will then give you this, because 0 times that thing would be 0. And then now I want to get x on its own. Let's multiply this out. Let's clean this up. So that would be 4x squared plus 16 minus 8x squared. And then x squared is like me saying 4 elephants take away 8 elephants. So that would be -4 elephants. plus 16. So now add this to both sides. That will then give you this, divided by 4, that, and then square root both sides. So so that will be plus minus 2. Plus minus 2. So you know that this will be 2, and then this here will be negative 2. If you want to know the height, the y value, then put this back into the original equation, and then it will jump to here. So you know the graph will look like this. There's only one turning point because well there are two, this at 2 and at negative 2, so we know it won't do this because here you have many points where the gradient will be 0. Anyway, your final graph will look like this. Your final graph will look like this, okay?